printed up and all set up to go. And what I thought I'd do today is, we got 2 days, and I thought today what I'd probably do is go through the things that are sort of related to what we're doing in the final, so you can focus on what you need to do. And then next class, I'll do sort of the same thing, but I kind of maybe during the day between, if you think of some things that you want to just look at a little bit more, we can talk about them. To begin with, one of the most important things that I tried to make happen in this course was to try to teach programming without actually doing a lot of programming. And so in order to do that, I used HTML. And the HTML, in the body of the program, calls the functions, the JavaScript functions up above. So instead of concentrating on just programming, we had this, originally what we had is we had the body, which is what the person who's using the computer sees. That's the stuff that they're looking at. Contacts the behind-the-scenes JavaScript functions and gives you answers. That's how we started off with the whole thing. And we pretty much stuck with that. That's pretty much how we follow through the whole course, is doing it that way. I should tell you, and I think I have told you before, that that's not the style a lot of people write in. They mix the two up and put them all over the place. There are some things you can do and some things you can't. So rather than have to deal with rules of where things should go, I thought it was just easier just to say, okay, we'll do all this stuff here, and we'll do all that stuff there, and then there'll never be a conflict. It'll always work out for us. And that worked out really well until the very last thing when we added the graphics part. In that part, we had to put some commands down in the body in order to get the graphics to work. But I thought that was a small price to pay. That wasn't very bad. So essentially, the idea is that I just want to begin with saying that the basis of the thing is that you have 2 parts of the program. You have the head of the thing, and in here, what we did is we put all the JavaScript. At this point, even right now, people don't pay attention to those things, but they're very important. So, and the JavaScript it's got its script thing up here, blah, 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 blah. And then it has a slash script here. So in other words, everything involved at this point should be just JavaScript, that's all. Screw up, so and then body. And the body of the thing, sometimes it's just a simple body statement, and other times it's a body statement with a style attached to it. And sometimes with an on-load attached to it. They're both there at different times. We'll talk about those in a second. And then in the body down here, this is the part down here that everybody sees. Then you have slash body and slash HTML. So these 2 things right here, what I was trying to get. The most important part of the course was to recognize this is what what people see when they look at the web pages, and this is where some of the behind-the-scenes action takes place, calculating or making graphics or doing whatever it does. Even at this late date, even now, just yesterday, in fact, I got something from a student online that had mixed these all up. It's hard to believe, but that's the whole point of the thing, is to keep these separated from each other. And as I'm fond of saying, and I've said many times, the problem with programming is that you have to be exactly right when you write your program. A lot of times the logic is perfect. It's just you make a typo and the program flops. On the final, you won't have that problem. You only have to write a couple lines of code in the whole thing. But the final, you just fill in blanks and true or false and everything. If you really know your stuff, if you actually knew this stuff, and a lot of you do, you could be out of here in 20 minutes. It's going to be very easy. You just have to write down what you know. Other people might have to go back to programs and look at them and see what the details are. So it won't be a very hard final as far as you don't have to write a lot of code. I wasn't. The whole point of the course is not to have you write code, but to be able to write it, just to link things together that are already pre-coded. So after we did that, after we did a bunch of that, we started introducing a couple of things. First of all, HTML itself, like the body, for example, has details that we started adding to. We wrote, like, for example, in the case of style, equals, do you remember any of the style things we did for the body?
Color?
Color? Which one? Background color?
Yeah, both of them, color, font color, and then background color.
Was it like this? Color. And colon, and then we put a pound sign, and then some now another thing, that's right there, I'm glad I mentioned that, because when you put a pound sign, the maximum you could have is FF. And that means that all the bits are turned on, and that means it's white, right? If it's 0, 0, 0, 0, 0, 0, 6 zeros is black. This is red, green, blue, RGB, okay? And that goes right here. And then you have to have quotes at the end. A lot of the stuff the problem with the style sheets is there's a spacing problem, and it really would drive you crazy, because if you have to do certain things, like for example, if you had a style sheet that said position absolute, do we have that? And then semicolon, and then something else like Z index, whatever you have. The thing is that if you have this right here, and you don't put that semicolon there, and you don't close these spaces on both sides of it, trouble starts. Some browsers will not read it, so it's got to be locked in really tightly here. And you got to make a distinction, and your eyes have to make a distinction between the colon and the semicolon here. Semicolon separates these items, but this thing right here says that this is the general situation. You're looking for position, and that's the position you're looking for, absolute. And you can have also relative in there, by the way. We've never used that. But what it does is, it says wherever the last thing is, go properly after it. It puts it in a place after it. And you can tell it how far after it. You can say, top and left, and that'll put it after it that distance. Just like it does from the original, it'll put it from the last thing if you want to put relative in there. But we don't use that. It's kind of, it's something they put in so that it would be, you'd have all the power to do whatever you want. But quite honestly, I've never even seen anyone use it, so I don't know. It might be one of those things that's there, but you don't really ever need it for anything. So just remember this about that you have to remember for the exam is the body has style sheets and it has on load. Now the official on load should be with a capital L here. That's the official one, but it works with a lowercase too, because apparently so many people are making mistakes they gave up and they just logged that too. On load equals, and usually what you have here is a function of some kind of a JavaScript, like a do this, and yet the quote marks, semicolon, close it like that. And the reason why you put these in the body tag is because when the program starts, you want to do it immediately. You want to do it right off the bat, okay? What I didn't tell you about is there's a JavaScript function called window.onload equals true. If you write that down up above, and you don't put it inside of a function, you just put it outside in the JavaScript global area, it will do the same thing as this right here. You don't even have to do this. It will start up immediately right away. I didn't do it because it cluttered up the JavaScript, and I wanted to, this is something that you do use for other things, so I wanted to be sure that we had this available, the onload available. But there are shorter ways of doing things. Maybe next semester I'll test that, but I didn't do it this semester. So those are kind of like the things we started off with, and then what happened was we started making the distinction between numbers and strings. If you have a variable, We give it a name, don't we? If you have a variable and you start off and you define it with a 0, it's defined as a number. Okay, it comes in, you said it's a number already. If you defined it as a string, you could have done that. You could say this, variable equals. There's different ways of doing it, but you could say stuff in here, whatever. So what happens then is you end up with a variable. It's just got a string in it. It's just a word, that's all. The weird thing is when the body is communicating with the JavaScript, down here you have a button of some kind. You know, we have a button that's an input. And on click the thing, on click, it goes up to some JavaScript function up here. The problem is when you send it up, let's send it to, let's call it, do this. Suppose this is the function right here, and in here you put, you just put that stuff there. No, it's an on-click, and you go to that function right there, and it carries this variable right here. The problem is the variable that it's carrying, which is something from down in the body here, the thing that it's carrying is a string. It's not a number. It's a string. It's always a string. The way we're doing it, we're sending up its value as a string here. So the problem with that is this: you have the function do this. And it receives that thing as some kind of variable. That variable right there is a string. So you can't say b equals a plus 1 and get what you expect to get as a number. It won't come in, it won't create a number. What it'll do is it'll glue the 1 to the a, whatever it is. In other words, if this comes up as some number 35, for example, but it's thought of as a string, it'll be 35 in here, but then what you get when you do this, it'll be 351 is what you're going to get. You're going to get a string variable. Because before you do arithmetic on the thing coming in, you have to convert it into a number. Remember that, that's essential. So basically, this right here, capital N, right there, for a plus 1, that'll do what you want it to do. What that does is it converts this as it comes in, because it's coming in as a string, converts it into a number, then it adds to it, and then you'll get a number over here. Instead of that 351, you get 36, if it was 35. And so you've got to remember this thing right here. What number does, what it's supposed to do is convert strings, which are words, to numbers. And another thing too you got to be careful of is that just because you have a string that has a 35 in it, doesn't mean that is not equivalent, that's not equivalent to 35. That's still, it's 2 characters, it's a 3 and a 5. It doesn't know it's a number. Okay, only that can turn it into a number. And you got to be really careful when you plus sign things together, because some of them glue them together and other things do the arithmetic. It depends on what you've got. The strings are, if a string is in the scene, like right here, a string is in the scene, the string dominates. It doesn't convert this to a number and give you 36. The 35 is a string. It says this is a string, and that plus sign must mean a string add, so it adds 35 plus 1 is 351, 351. So no, it's a string add unless you do this right here. That's pretty clear, I think, right? Does that make sense to you? But I want you to be sure you know that part right there. Strings have a lot of things. We've done quite a few things with strings. Maybe I got a little list of them. Maybe I should, yeah. I just want to go through them. We did the number thing, and we just did. If I said my name is space right there, there's got to be a space here, plus Joe. Like that. If you did that, what you'd end up with is my name is Joe. And we've used that in several programs below where we said we asked somebody what their name is, and then we sent their name up to here as A, and then we said this right here, my name is A. which will do the job. If they typed in Joe, and A is Joe, that's a string, so it'll add these string to this string and send it out to them. When you're sending stuff to the JavaScript, okay, you use the name of the variable that you define. You give it some name down here, okay. It has an ID of some kind, okay. So the ID is its name, whatever it is, of the variable, whatever. This is down in the body now. You take the name of the thing. And if that's a text and you put some information into the thing, and you want to send it up to here, you have to send up, you don't send up name, you send up name.value. And the reason why is because what we're sending up is, there's different things you could have. You could have name.length, for example, which is how many characters are in the thing. There's dot several things, and we didn't use any of those things. What we were concerned about was I just wanted to get a value up to the JavaScript. So that's all we're concerned about is the numerical or string, actually string value of the thing, and we wanted to send that up there. So therefore, when you send a variable with an ID of name, like this is text of some kind, text, like that. If you have this line right here, and you type something into it, what it's going to do is when it sees this line, it's going to create this, of course. And whatever you type in goes into name. And then what you say is, when you do the function, it'll send this value, which is whatever you typed in, up to the function. Okay, and it arrives up there in the function as an argument. So you just so you get the basic idea of what's going on here. The reason why I'm talking about it, by the way, is not for you guys in the room necessarily, but there are people online who, for some reason, have never understood what we're doing here. Even at that level, they didn't understand that that's what we're trying to do. If you have a string in JavaScript, supposing it's oops, again. Well, you have that string right there in JavaScript. If you write this down, if you say variable, the length of that string, give it any name you want here, is equal to stuff dot length. What you get is 1, 0, well, actually it counts it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This will become 10 over here, because that's the length. The length means the number, the count of the thing, okay? If you put any variable that you have, and you ask for its length, it will tell you how big it is. Now you remember when we did arrays. The array is a different thing. An array has several things in it. So if you have an array, for example, variable x equals, then we did this. And we said it contains like hello, bye, etc. Whatever, it contains these words here. This is an array. This array contains 3 things. If I say x.length here, I get something entirely different. What happens here is I get 1, 2, 3. I get the number of items in the array, okay? Which is different. If you just have a variable and you take its length, it'll take how many characters are in. If you have an array, if this is a whole big array, it'll take how many elements are in the array, okay? So, but that's something we didn't use very much, but we did use it a little bit. I'm skipping around here a little bit, but now that we're talking about this, I want to talk about, I want to be sure I get all of the critical stuff. We did the if statement, and we didn't spend a lot of time on it, but we ran a few programs with it. If I were to say to you, I have a variable, a equals 3, and another variable, b equals 5, like that. If I have these 2 variables, and I say if the question is, what would happen? Would this thing alert or would it not alert? What do you think?
No, it would not.
No? You say no?
Well, A is 3 and B is 5.
Right.
Oh, greater than it. No, yeah.
So it wouldn't. What do you think? No? No, it wouldn't, right? because this says if A is bigger than B and A is not bigger than B, A is littler than B. It's not equal to it, it's littler than it. Oh, what if I said this though? Would it do it then?
Yeah.
It would do it then, right? Because now it's A is less than B. Yes, it is. A is 3, B is 5. It's less than B, so it doesn't. These are very important things when you're writing programs. It's the only programming kind of thing that we really did that was. It's the kind of thing that does stump students sometimes. Get used to the if statements, what they do. What you have is you have these possibilities. You can have A is equal to B. You got to have two of those things in there, right? You can have if A is greater than or equal to B. You can have if A is less than or equal to B. By the way, I want to point out that remember the equal sign is always over there. The greaters and less than signs are always in the front over here. Okay, so that's the way it works. You can have okay, so you can have if A is just greater than B, you can have that. You can have if A is less than B, like that. And there's one more. It says A is not equal to B. It looks like this. A is not equal to B. That's the only one. It's an exclamation point. And those are the 6 standard ones that all languages have these. That all computer languages have these. So if any of these possibilities are, you can express anything. By the way, you can also test things in different ways, but I don't want to get into that now. I mean, sometimes you can test the thing one way or another and get the same answer different ways.
So what does an exclamation point mean?
I'm sorry?
What does the exclamation point mean?
What is X? That's not equal to B. It means not equal to B. Other languages do it a little bit differently, but this is pretty much like standard. This is the most standard way of doing it. And they may even have a JavaScript variation of this. I don't know. I don't ever use it. There might be one. Most of the code that we write, very little of the code that we've written cannot be used in C language, C++ language, and even with a little bit of fiddling around in Java, you could actually use it. It turns out that all the languages kind of use the same kind of syntax. It's just that they vary them because they have different demands, and they want to make sure that when a person's writing in this specific language, that they know what language they're in, so they'll know what they're doing, so they won't accidentally write code from another language. So they make things look a little differently. Okay, we had a language called Pascal that they used for years, and Pascal sort of looked like that too, but it had maybe a colon here or a semicolon there or something like that. Like they might say something like A colon equals to B or something, always some little weird eccentric thing that would remind you what language you're in, that you're in a different language. But also another thing which I mentioned before, that I'm not going to ask you a question now, but the language, in this particular age, they have what they call object language. Everything is done in objects. So instead of writing code like do this, do that, do this, do that, do this, do that, a big long program, they'll have a bunch of basically functions that are created in advance. And what your program does is simply goes to this function, then to this function, then to that function, and it jumps to these different functions. That's how it does it. So it puts little objects out there. And those objects contain two things. The objects contain variables, which they're defined within the object. They're variable names. When we say new in our programs, when we create these planes and cubes and all that stuff, we're actually creating objects. That's what we're doing, creating these objects. And these objects have properties immediately. You don't know that because we never use them, but every time you do that, you create an object, and the object has a length and a width and a position and a rotation. It has all these different things. So you can say the object name dot rotation, and have it equal something. It'll tell you what it is, what its rotation is right now. So in other words, we've created these little functions. I created them, put them aside, and I called it the include files. So when you say make a plane, you say new and you say plane like this, and you put a bunch of stuff in here, it goes up to one of these functions here and it creates the plane. And it creates a plane with lengths and widths and depths and rotations and all kinds of stuff immediately. So later on, when we say up here rotation of x is equal to something, that's because it's been defined up here. It was already defined for that particular object up there. And we say we want to rotate this, it's also got its own rotation things all defined too. And that's the reason why we have to say up here, we have to say plane position dot x, y, and z, so forth. Plane is this object we created. That's called plane now. And this is position. It's defined in here. It's got a position. And it's got a position of x. So these things are defined the minute we create those things. By saying new, we create them. And it's different than calling a function. What a function works like this. A function says, there's a little machine up here, and it will do something for you. So you call the function, it does its thing, and it sends you the answer. And it's over. The function dies and it goes away and there's nothing else left of it. What we're doing is we're calling this thing right here. It actually creates something new, a new thing. And it has numbers, values in it that live after it comes out of there. They're all still alive. So we can use them in our graphic stuff up here. But that's the thing that was behind the scene to us. I didn't emphasize it and didn't even talk about it. And so if you ever take a computer language, you can be ready to see this kind of stuff come out. It'll come out of the woodwork. You'll see variations of what we're doing. Let me keep going here. We did this one here. I only used it one time, and I think case, that should be capital C, I believe. Yes, it is. I think there. What this does is if you have something come in someone's typed, and you're trying to say, well, if they said banana, do something, but they might have put a capital B on it instead of a lowercase, you can force everything to lowercase, so when you make the comparisons, they'll always match. So in other words, if they type capital banana, and down here you're going to test it against the word banana, you don't put capital, you put lowercase banana, it won't find it. Okay. But if you run it through this thing first, this would be my word here would contain the word banana. What it will do is it'll take the variable and change it to lowercase banana, and then you'll have a lowercase. Then when you do the comparison with yours, it'll work. It'll actually see the thing. Because upper and lowercase are different characters, and it doesn't see that. We had another one here, which was this one here. My word. I'm showing these because these are the ones that are right on the edge that you have to look up, and it's a lot of work to look them up. This is called trim. And all that simply does is if you're looking for a word and they type in, for example, what is your name? And your name is Joe. And instead of typing in Joe, they type space, Joe, space, or something. So the space is all around it. So if you went to compare it to the word Joe, you wouldn't find it because the spaces that they typed in would confound it. What this thing does here is it trims it down. You put it over here. What it does is it takes off all the spaces on the outer edges and squeezes it in. So therefore, you just get what they typed with no spaces on the outer edge. It doesn't take the middle ones away. It just takes the outer ones. So so these two guys right here are very handy when you get strings coming in from people and you have to you're looking for something and you can't find it easily. And speaking of looking for something, the most common way we've been looking for stuff doesn't care about these things unless the word itself is upper or lowercase. But this is a common thing we've been doing. We're saying variable position equals whatever the word, let's say expression. Dot index of this. This thing right here is a very, very handy thing to have to be able to do. What this thing right here does is it looks in this expression, whatever it is, the words that you have, it tries to find out if this word appears in that expression. And if it does, it finds out what position it's in, and it puts that position over here. Otherwise, it puts a -1 in. So in other words, if you do this thing right here, it will look at any sentence you have to see if it can find the word this or whatever word you put there. And if it finds it, it'll tell you where it is. If it doesn't find it, it puts a -1 in there. So what we were doing is, through a bunch of our programs, we said, well, if position is greater than equal to or greater than 0, then we would do something. Well, I think that's the way we did it. And basically what I was saying was, if it's minus, it's less than 0, of course. So anything from 0 on up means that you found something. You can find a 0, by the way, this way, because if the expression was like banana, for example, this right here is the 0th position. So 0 is an official, that's a find. If you get a 0, that means it found something, only it was in the very first position, because it starts off at 0. And so what that does is, what this combination does, it allows you to look through expressions to find anything you want. We've used these before, but I'm just bringing it back up again. There's a couple of other ones here which I showed you, and some people have used, and it's very handy to use these things. It's a substring. If I have an expression up here like that, and I say I want a variable C equals write that substring thing. What I'm saying is, I want all the characters between 2 and 4 out of, wait a minute, I didn't write the whole thing, stupid. I gotta write B, sorry, gotta get that B in there somewhere. Gotta know what the substring are. So in other words, you got this variable that contains all this stuff right here, and you want to take a piece of it, starting at character 2 and ending at character 4. Now, here's what the problem with it is. This, as I mentioned to you earlier when we did this doesn't quite work the way you want it to. It takes everything except 4. It won't take the 4, it'll take 3. It won't go all the way to the top. So it'll start at position 2, which is 0, 1, 2. So it'll start right here at the C. And then if you say 4, it won't take that. It'll go to 0, 1, 2, 3. It'll take up to this one here. It won't take the 4th character, which is kind of disconcerting. Okay, so you always have to say a number bigger than the one you want. So if you want to take 2 to 4, you'd have to say 2 to 5 in order to get the 4. That's one of the problems with this one. The other substring one is the one that really works well. It looks like this. C equals B dot sub str. It doesn't have the ing part on it. If you say 2 to 6 or something like that, what this one does, it says something different. What this one says is start at character 2 and take 6 characters. So you got the 0, 1, 2, then you take 2, 3, 2, 1, 2, 3, 4, 5. Oh yes, whatever. I didn't put enough characters in. But basically, that's how it does. One of them starts at a character and ends at a character, and the other one takes a number of characters. This one takes a number of characters. So you start at 2, and you'll take 6 characters. That always works exactly as you want, including the character 2. It'll take all of them. Okay. So this guy's the good guy. This guy here is a little bit awkward to work with. You just have to remember that that number has to be one bigger than the one you want to take. So in other words, it'll take 2 and 3 with this command. It won't take 2 and 4, 2 to 4. It'll take 2 and 3. If you wanted to take 4, you have to put a 5 there. Then it would take 2 and 3 and 4, but it wouldn't take 5. And that's the idea. So that's how the substring ones work, and they're very handy for looking. We've done it a lot of times, looking for things. Okay, and I think the plus sign we did. We pretty much have done all these things. That's about it for strings. That's what we did. These were early on, so I don't know how much you remember of it. We did our sound stuff. And the sound things, I don't require you to memorize, like, whether it's lingo or this or that. Those are just includes that I invented. But what I really want you to do is be sure you understand how all the sound stuff works. The basic synthesizer, voice or speech synthesizer, you don't need any include for. You just put in you make the message up and you tell it to say the message. So that one's an easy one. That's nothing going on there. The one that are complicated, the ones like with foreign languages, okay. And what we did was, I think I think we used Lingo. Wasn't that the foreign language one this semester? .js or something like that. That might have been it. It's one of those. But anyway, so we had to include this one. And the reason why is because we had to go up to this function and tell it to change the speech that it was using, what kind of accent it had. So that required you to you had to send something up there. So what we were doing is this kind of thing here. We said, we said go to, let's see, was it speak, I think it was speak. I'm going to write speak, but I'm not sure if that's the right word. Say speak. I'm going to call it speak. There's a function up there that we have to, whatever it was. As I say, you don't have to memorize these. But the whole principle is you have to say a function, then you have to say the words, whatever the words are that they're speaking, comma, and then you have to put down like Italian, like so, or German, which is DE, or English, which is EN. You have to put something with it when you send it up there, because otherwise it won't know what language to speak it in, okay? And the words can be in the actual language. This could be an Italian expression, and then it would seize the IT, it will actually speak the Italian in Italian and with the proper accent. So we had a program like that, and I think we called it Babel. I think there's one called Babel up there that does that, like Tower of Babel. And so that was the speaking programs. The speaking programs have a little bit of a problem. For some reason, some days on some machines they'll speak with a male voice, and other days they'll speak with a female voice. I have no idea why that's true. It's something to do with what Google's doing. It has nothing to do with us. But the normal speaking voice, it changes from day to day and from machine to machine. Sometimes, I found out that sometimes some programs I have that are old, they always speak the same way. They never change. But if I recompile those programs, if I write them up again, they change again. They start to change again. So I'm not sure why that is, but it has nothing to do with us. It has something to do with Google. So in other words, what kind of voice you get is a tough thing to anticipate. Except that you can actually force it to have a voice. You can force it to have male or female. And what you have to do is, up in the lingo file, the include file, there's an area where it says you can say, make it a female or make it a male voice. You can actually do that. I didn't show you how to do it. It get into too much complication. So I left that out. But maybe for the sake of good fun programs, you might want to not have George Washington speaking with a female voice, which someone had sent that to me this week. So maybe I'll fix that so that it works. Like I say, any of these things that we're doing now, they'll exist later on. The only thing is going to be different next semester is the graphics. The graphics calls for 3D graphics is going to be a lot more stuff in it, and it's going to be like some of the things that you use now may have to be written in a little different way, and I'll show that'll be online too. If there's any fixes needed, it'll be online too. But I have to. Some things I have to change. I can't get away from it. Okay, so let's see. I'll just look at what I got here. Oh yeah, we got a bunch of things here that I should talk about. The set timeout. It's got a capital T. Yeah, it's capital T, right? have this in it. What will happen is, when it comes into the function, it comes down and it bumps into this line right here. And what that line says is, up above you have a variable called speed. And what speed contains in it is milliseconds. It contains a number of milliseconds, okay? And what this timeout does is a very weird thing. It comes down and it bumps into this thing and it says, well, wait that amount of time and then do this again. So what it does is, in this case right here, what it would do is it would run the function, whatever you did in here. It would bump into this and say, okay, wait 30 milliseconds and then come back in and do it again. Come back to the program every 30 milliseconds, or however long you make it, okay? The advantage of that is you can get it to do things that you don't have to deal with anymore. So for example, if you had some kind of an animation with a character moving across the screen and you wanted the person still to be able to use their computer and talk to the program, what would happen is this thing here would it would start going like this on its own. But while it's doing that, because it sets this thing and then it falls through the function and it's out of it now, it's out of the function. So it comes back to you and you can do anything you want. You can say, okay, listen to the keyboard, do this, do that, do the other thing. So while this thing is doing its thing, making the character move across the screen or whatever it does, you still have complete access to the computer. You can talk to it or listen to it or put stuff in. You can run the program at the same time because this thing's not running against you. Theoretically, it's running in a different thread. They say that JavaScript can't build a different thread, so they must do it some way. I don't know how they do it, but threads simply means you can have two things going on at the same time. They're using the same computer. They share the same CPU, or CPUs. But what it does is it lets one program do a little bit, then the other one does a little bit, then this one does a little bit, this one does a little bit. But they're all so fast that you can't tell they're not being done at the same time. This thing's doing the same thing. This thing right here is counting and waiting to go in again. And then when it goes in again, it starts doing its stuff. You're doing something else out here. Meantime, you might be writing something, or the user might be, doing whatever they do. So therefore, this thing right here is like it is like another thread, and it gives you a terrific ability to do stuff and have it continue to do it while you're doing something else. And that's a little bit of a tricky thing to use, but that's it right there. We use set timeout. We don't do that in 3D graphics. We have a different one, an animator, which is a different strategy. The reason why they're different is set timeout is it waits 30 milliseconds no matter what. It just does that. With the graphics one, the one we use, the current one we're using now, which is to go back to the it just keeps recycling. It is actually says when this frame is on the screen, begin to develop the next frame. So in other words, it only basically waits until all the work is done, then it jumps immediately back and starts creating the new frame. This one, the 30 millisecond one, always waits the same amount of time between frames. So in other words, a frame, if you have faster frames, they'll run faster in the 3D graphics. And that's because there's so much work to do, they can't afford to dilly-dally. So what they do is whenever they get a frame put together, they throw it right up on the screen. So you see the animation kind of running. It's actually irregular, but you don't notice that. They've got it rigged so that it doesn't show that too much. Anyway, that's the timeout thing, and we did a little bit of that. Let me see what else I got here. We did. What I probably should do is go online, get the videos running here, and go through some of these programs. Because for me to write these things down take too much time. But I can. What I'll do is I'll run some of the programs. We'll stop off looking at the stuff in the early programs, and you'll see what we did again. The things I'm looking for that we did. I know you know what we did, but I just want to be sure that we focus a little bit on what I want to be sure you're going to be able to do. We have. I have like a list of items that you should pay attention to, and I'll have it online tonight. But it isn't really inclusive. It doesn't include everything. We covered hundreds of things, and there's no real way to but I can put enough on so that you'll be able to look everything up. So at least so you're prepared for the exam. It isn't that bad an exam, but just to be sure that you're in the right ballpark. Kind of curious about something. Oops, sorry. Okay, so let's just start rolling through here. Let's see what we got. These things. I'm not going to ask any questions about Alta Vista. You guys, obviously, you've used that so much, you know how to use that. So we won't talk much about that. Class 2. In Class 2, I guess I probably got to the point where all we were talking about here was just the difference between the body and the head, that's all. There's nothing going on here. Class 3. This is the Macintosh dilemma. Nothing going on there. Class 4. JavaScript, that's why I introduced the JavaScript we talked about a couple of minutes ago. It's just the JavaScript is different than the body. There's something to trip up there. This right here might be useful for anybody who has any problems with how JavaScript is used. I don't think anybody does, but it actually shows you JavaScript programs, and it shows you the head and the body, and in red shows you what the program, how it deals with it, those things. But I think that you're all pretty much okay with that. Class 5. At some point I introduced the include files. And the include files were, that's where you have code that's hidden from you that you call the code, but you don't ever have to write anything other than just call it with a function call. I never get into that in detail. Some of those include files are very simple, by the way, just simple formulas and stuff. But what I did was I wanted to keep you away from dwelling on working in technical stuff that was just, it required too much explanation, so I didn't bother. I didn't go into it at all. Anyway, so what's in those include files is just inaccessible. You might just as well forget what's in there. There's nothing there that's important to us. Speaking programs. This is the simple one here, I think. You write a phrase, yeah, and see what it looks like. And there it is. You see, this is the one that doesn't require any include file. Let me bring it up bigger a little bit here so people can see it. All it requires is you set up the message and then you say talk. That's all it does. This is the one that varies. Sometimes it speaks with a male voice, sometimes with a female. It varies a little bit. I don't know why. But that's the one there. In fact, this program contains everything that we basically just talked about. Down in the body, it has a style, and in this case, the style sheet's asking it to text a line. But notice it's the category, and then it says colon, do that category. So in other words, the alignment is centered rather than left or right or anything. a semicolon, that's the important, colons here and semicolons here. By the way, one other thing, if you were to put text align center up in JavaScript rather than in this function right here, in this body, in the style sheet, the normal strategy is it would look like text, capital A-L-I-G-N, like that. Sometimes what they do is, instead of putting a minus sign, because that's an arithmetic process, they don't want to see that in JavaScript. So what they'll do is they'll squeeze that out and they'll make the A a capital. So what you see is the word text minus align colon center in the regular HTML CSS looks like that. But if you did it in JavaScript, what it would say is text capital A-L-I-G-N equals center. That's how that would look like. It wouldn't have colons either. In other words, it would have JavaScript kind of dialogue, which is not these colons and minus signs. So you can say the same, anything you can say down here, you can say in JavaScript, but you have to change it. For example, font size would be font capital S-I-Z-E equals 40. That's how you would say that part right there. So there, you can do any of the things in both. And all JavaScript's doing is trying to accommodate HTML because it's built based on it. But it has to also be a programming language, so it has to be careful about how it does everything. Let's keep going here. But that program is kind of cool because it kind of shows basic stuff we're starting to do. Didn't care about that. This right here, actually, we did talk about a little bit, and it's probably worth you looking at sometime. When you position something right here, let me bring it up again. When you, this is a style sheet. Notice what I've done here. This right here is an image, and the source of it is cbed.jpg. Basically, it's a picture, okay, and that just wraps around to here. And the picture has a style associated with it. I want to put it in a specific spot. So I say I want to position it absolutely, and I want to position it from the left 300 and from the top 300, and I want it to be -2z index, which drops in 2 places into the behind the surface. And that right there, that style sheet right there, is a classic. And basically what it does is it allows that picture to be put in a certain position, so I can put stuff in front of it, I can move it around, I can do anything I want. But it starts in the place I want it to start in. That's the critical thing. Left says where from the X direction, and top says where from the Y direction. By the way, that's upside down. You start at 0, you go to 300. If you increase that number 300 to 400, you wouldn't go up, you'd go down on the Y direction. Because the bigger the number, the lower you go. It's upside down. You gotta remember that. And the same thing with the portal. I just put these 3 things in different layers. That's all basically what's going on here. We wanted to have them in different layers. And one of them, let's see, with pink, one of them's a GIF. So the GIF was wiggling. The seedbed was behind the GIF because it was a -2 index. The GIF was at 1, and the porthole was at 2. So the 3 of them were layered, and the fish was wiggling in between the porthole and the background. That's all that was going on there. But those kind of commands you should be familiar with, the Z index and that stuff. This is a simple function. Whoops, that's a movie. If you want to watch a movie. Video. Some of these little videos are handy if you got any questions about how to do stuff. Yeah, that was it right there. The reserved word problem. We didn't dwell on that a lot, but it is a nuisance, and there are a lot of reserved words. I just clicked the thing. Let's see if we can get them up here. There we go. Come on, show me reserved. I'd like to see the list. There it is. Look at how many there are. It's a huge number, and you can't use those words for anything else because if you do, it'll confuse the programming language. There's so many of them in there. I'm kind of disappointed. Words like try, I mean, words that are kind of switched, normal words that you use, you hate to see them, used up by taken away from you. And it's not uncommon to use words like name and stuff, so that's not very good. But that's it. These words are truly words that will get in your way. If you have a program that's causing trouble and the word you use sort of has a little bit of computer texture to it, see if it's a reserved word. Video. That's a good one here. Count the penguins. Oh, yeah? So every time I click the button, it adds one to the to this thing over here. It's a very simple program, probably worth looking at. There it is right there. What happens is you got the body down here, and you got a button, an input button. And when you press the button, it goes to count them as a function. Here's the function where you count them. And all count them does is a variable. By the way, that's another thing I should mention, that if you're going to have something that's going to maintain its value, every time you go into that function, you've got to have it defined outside the function, because if you define it inside the function, it'll do something, but then when the function stops, the number goes away. So in this case, we want a count to survive every time we want it to still be there. So I defined it outside the function. So when I said add one to it, it added one to this, and when the function died, it was still out here, still alive, and we could count again and again and again. So all this thing did is when you press the button, it goes up, it adds one to count, and puts it in count, and then it puts the answer out on the screen. Out1.value equals count. Just simply puts it in this area right there, out1. And dot value is what's in it, and just puts the value in there, 1, 2, 3, 4, and so forth. That's a kind of a nice little program. It's clean and it doesn't have anything that's hard to figure out. Penguins. This one here, all this one was trying to do was give you some practice with multiplying, doing some simple arithmetic stuff, I believe. Right up here, function, you put in the rate and the time, and all it did is it has to translate that rate into a number and time into a number also. But it just multiplies them together and gives you distance, and then puts the distance in the answer. There's nothing much going on there. So basically what you have, again, is a place for you to type in this number and that number, and then a button. Then it goes up and multiplies them together and gives you the answer. It's a simple program, but it's got everything we do regularly is in this kind of program. The beginning program is very clean and nice to show you those things. Speaking program, we have this one. Read the words we type in. These are just text to speaking. We did a bunch of that. Use speech synthesis. Okay, this is a different one. Now, well, no, this is the same thing, except I think it's more complicated. Let's see what this one looks like. No, that's just
in this video.
Good explanation. Index of. Here's an example of the index of. Oh, just not an example either.
This video.
In the video. It illustrates string. Okay. Yeah, this is the if statement here, but I just talked about it. But let's just see what it looks like. Yeah, I see if A equals B. Don't forget you need two equal signs when you say if something equals something else. You need two things in here all the time. It requires two items all the time. Nothing new here. This is greater than B. This is less than B. There's nothing going on here really. I'm just testing to see if something's bigger, smaller, or equal to. Here. This I think is an index of, if I'm not mistaken. Maybe it is, maybe it isn't. Let me see what this looks like. Yes, it is. So you go to the function, and what it does is it looks for the word yes, and it looks for the word no. And it finds yes, it puts position 1, sets it at some value where it was. When it finds no, it sets it at this value. Then all you do is just what we did before. You have an if statement that says, well, if 1 is greater, that means you found it. And you say, I found the word yes. Or this one's greater than or equal to 0, you say you found the word no. You just say whatever, you send that value out to the answer, whatever it is. So these programs are simple too. That's kind of a simple thing. Let me just come on here. 7. I'm probably going to have to do a little of this next time. We talked about that here already. See, this is just the early stuff that we talked about, how to do indexing and stuff like that. This right here was how to get, I don't know how much we talked about this, but there's two things going on here. You can either put http://.word/com/ the name of the file, or you can just put the name of the file. But if you just put the name of the file up there in the include, then you have to download it to your machine from me. And then that means if you write a program in Alta Vista for it, you've got to upload that file as well as your program. In other words, that file has to follow your program wherever it is. So if I have a program up there that uses this include, and you run a program down here, it's not going to know it unless you say .works blah 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 and finds it. Or you can take this program and download it to your machine and then just give it the name graphics, for example, and it'll run it because it's in your machine. It's just a question of when you use something and include it, has to have the stuff right in the folder with your program. I'm not going to ask you about that, but that's down the road. The animation stuff, we started doing animations here to move things on the screen. Basically, where is the thing? Where is the character? It's here someplace. Yeah, there he is. If you hit the left button, it moves to the left. You hit the right button, it moves to the right. Left button, it moves to the left. This program right here has 4 buttons in it. There's the 4 buttons right there, left, right, up, and down. And each one of them they all go to the same function, but they carry an argument, either left, right, up, or down. So in other words, this my words, when it gets up into this function up here, it has either one of those 4 words, left, right, up, or down. So what you do is you say, well, my words equals left, move the character to the left. If it says right, then you move the character to the right. If it says up, you move the character up. And if it's down, move the character. So you have 4 if statements asking if my words contains any of the 4 words from down here, and it acts accordingly. Now, to move the thing, that's a whole different deal. If I want to move something, for example, if I want to move x location equals x location minus 10, what I do is I maintain the location of my character right here. That's its x location, that's its y location. And what I do is, down below, this right here is the same thing. He's left 1,000 and he's top 500. Just the same as up here, left 1,000, top 500. So what I do is when I want to move them, I say, well, change x location, subtracting 10 from it, and then tell the style sheet to put the same number in its location down here. So it changes to 1,000 to 1,010 or 900, 990 or something. So in other words, what happens is when you call this thing, it does an arithmetic thing on the numbers that you have here, and then it puts those numbers into this source down below here, so they'll both be the same all the time. But once you put it into the source, the character actually moves. This thing doesn't do anything, it just holds the information for you. This one down here actually does the move. So you have to have these 2 numbers set up equal in the beginning. Had some students who set this different than these 2, and it didn't make any sense. Their pieces weren't, nothing was moving in the right place. That's a common. This is something you have to do with the way our strategy and other programs, other languages and stuff, you have to do it this way. We worked with the clock. I think we worked with the clock. Right here in the dark. And the clock has a second hand, a minute hand, and an hour hand. But if you look at the program, it actually can have a lot more information than that. You can have the date, the day of the week, you can have all kinds of stuff. But this one doesn't have it. This just has the seconds, minutes, and hours. Okay, that's all it has. But actually, let me see if I can find the other program because it does, well, you can probably find it yourself. It's this one right here. Source. This right here, this stuff right here, I'll blow it up a bit for the people at home. When you have a clock up here, JS, what happens is when you say these letters, you have to get the time. You have to ask for the time. Okay, that has to be done. And what I did down here is on click, notice there's a button down here. When you click it, it goes to the time. And when it gets up here, what it does is it comes to the time. It reads all these time things, JJ time, JJ week, JJ month. It has all those things immediately. Okay, once you say JJ time, it has all these guys right here. And then what you're doing is you're simply putting them into your output location. So when you run this program, all it does is it shows you what the computer thinks the time is. So when I press the button right here, I press this button, this simply goes up to the function, reads JJ time, and then puts all the times into my locations. So that's all the information you want, and that's computer time forever. Okay. At the bottom, how to get down there. Keeping track of where the mouse is. When you're rotating objects, we did a lot of work with the mouse. We had the mouse picking, grabbing, and dragging, and so forth. I think I'd like to do that manually on the board, but the basic idea is that when you want to use the mouse in the body, you have to say onload startup. You have to go to the startup thing. Okay. I just wrote a new version. It doesn't even require that anymore. Basically, if you include the mouse thing, it automatically comes to life. But what happens is when you hit anything on the keyboard, use the mouse after that, it comes back and gives you information. If you want to use it, you can. It comes back to you. And so therefore, that information about where the mouse is or what key you hit, all that stuff with mouse key is there available for you. You can use it or not, whichever you want. The one thing you've got to watch out for, and this is the problem with it, is that in order for me to do that, I had to deny the browser access to the mouse and to the keyboard. Because if you hit left and right key on the browser, it moves things around, it does crazy stuff. So I didn't want that to happen. I wanted the program to completely lock down the mouse and keyboard. So what happened is I denied the browser the access to it. So therefore, things that you normally would do on the keyboard won't work once you're in this program, once you've set mouse key, because it captures everything and it defaults to not letting the browser know anything. The reason why is because if you want to do something, you don't want the browser to start doing things too. Everything starts to work and it would drive you crazy. So I had to do that. Rotation. We did a bunch of rotating objects. See here. Rotate. Here's one right here. It's our basic rotation program. And the rotation program, I'm going to end with this, by the way. I'll just talk about this a little bit. It's one of the things that I might ask you about. When you rotate, use this WebKit transform, okay? This is the name of the object rotating. This is the style sheet. It's going to be in the style sheet. The WebKit transform is in the style sheet. You can put that in the style sheet down in the body if you want, but there's no point to it. And then what you do is, this stuff right here, this is a weird thing, and I want to be sure you clearly understand it. We're sending something to the transform. We're sending something to it, sending a function to it. And the function's called rotate. So we in quotes, we put rotate, open parentheses. That stuff right there, that gets sent to the function. The function's going to deal with this thing. And then we send it plus degrees, which is the number of degrees we want to turn, plus the word degree. If it didn't have that word degree right there, it would assume this variable was in radians, and it wouldn't go to the right place. So by putting that deg in here, we're telling it, these are degrees we're sending you. And the reason why is because it's so much easier to think in degrees. You get 360. I mean, what is 0.7? Where is that on the circle? 0.9. In radians, it's very hard to know that. So it's better to work in degrees if you can. And so what that does, all this simply does is it rotates an object, whatever this object, image 1 is, that many degrees. That's all there is to it. Again, this has a time, because the wheel keeps rolling, we didn't want to stop it. I had to set timeout, and every 30 milliseconds it goes back and does it again. So it takes the wheel and it goes bloop, and it goes bloop, 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 but every 30 milliseconds makes it look like it's moving smoothly. And that's it. I think that's pretty much, next time we'll just hit the rest of the stuff. We have to go up through computer graphics, and that's a lot of stuff, so I'll leave it for next time. Like I say, you don't have to memorize all these things, but you should know where to find them if you don't know the exact syntax. And I'm not going to ask you to know syntax. I'm going to put it down there. I'm going to say, do you recognize this? Do you know what this does? That's the idea. The whole idea of the course is, do you know what this stuff does when you see it? And that'll keep you from having to, spend 10 hours memorizing some kind of stuff.